Ji, thank you.
Okay.
Thank you.
So in this presentation or in this topic, we'll try to understand the concept that if we have the time varying data, how we can model it by using enhanced entity relationship models or any other models we have to conceptualize that data. Because at the end of the day, what we have to do is we have to map it into the database. So it means mapping means that we must have symbols available for all those ontological concepts which are related to time. So models and modeling. Why there is an importance of model? A collection of model is the best way to describe the requirement for an information system. Of course, a model is what? Is a representation of some aspect of the system being built. Model of any kind. Let's suppose if you want to build some sort of engineering product, you need a model. You have to build a model, and of course, on the basis of that model, you go on and to achieve your task. When we are building a model, there is some theory which is attached to it. There is some theoretical approaches. There are fundamental concepts which are attached to that particular topic. So model is required everywhere. Let's suppose if you want to have a civil work, you need a model. You want to have, you want to make a computer application, you have to model it. You have to, when you are building databases, you need a model. And model, when I say generally a model means anything. Let's suppose sometimes we model things mathematically. What we do is that we develop mathematical equations, mathematical models, and we transform them to build that particular system. So model is of any kind, but right now we are talking about conceptual models, and we are talking in the context of relational database models specifically. So of course here we are referring to the extended ERD models. Because of complexity of a system, a variety of models should be created to present the detailed information collected during the analysis phase. So why the model is required? A model is required to represent the system. And of course, whenever we are representing the system, systems are complex. So what model does actually, it makes it simple. And you can simplify the concept and you can see yourself that how it work out. So for one task, we may have several kind of models. It is up to us how to pick which one is the best model which can be adapted in that particular situation. For example, आप मॉडल कर रहे हैं किसी भी फिनोमिना को, मिसाल के तौर पे ग्रोथ रेट को फिनोमिना कर रहे हैं. फॉर एग्जांपल, you want to model the COVID situation right now. For example, you want to model the water flow or the employment patterns or the economic side. Whatever you want to do is, whenever you have, there are certain parameters which are involved. There are certain things which are important, which are relevant. Obviously, you define the scope, and then you try to build a model, to select a model, and then you apply that model to solve that particular problem. Sometimes model fits very well to the given situation. Sometimes we believe that no, this model is not that good. So sometimes we have to make amendments, we have to make changes, alterations, for example, and then we apply those models to the problem. The reason is we want to simplify it, and जो उसकी जो complexity है उसको हम resolve करना चाहते हैं. Many models are graphical. Here, when we talked about the extended ERD model, the extended ERD model is obviously graphical. So as I discussed earlier, that there are various kinds of models, and here what we are talking about the graphical model. When I say a graphical model, it means that you have some representations. Then it means that you have some symbols which defines various concepts, and you use those symbols and you try to build a model, and that model explains everything, that how actually you have means you understood the concept. So many models are graphical. For example, data flow diagram itself is graphical. You studied the class models, class diagrams. They are also graphical. Why? Because they have certain notations, how to represent a class, how to represent a subclass, how to define a method, how to define a private one, how to define a public one, aggregation, composition, inheritance, all of these, what you want to do is you want to express it in the class diagram. So everything has its own representation. So once we have the class model with ourselves, then we can easily understand that what is the behavioral aspect of the object, and obviously that will help us to build those classes, to create those relationships which exist among those classes, to create those methods, uh, and obviously then we can see that how that works. So if the solution, whatever the solution you have, whatever the model you have applied, after that what you can do is you can execute it and see that whether it works well in the given situation or not. So can show different levels of details or the level of abstractions. And whenever we can say level of abstraction, yes, model itself is always an abstraction. And when I say the levels of abstractions, of course it means how much information you want to introduce in a particular model. So model itself can be a simple one, can be a detailed one. For example, you talk about data flow diagrams, which represents the data flow among all those processes which are there. And you can see that how one process gives an input to another process, and how the other process gives an input to other processes, maybe the parallel processes. There may be some information you want to save. So there are concepts of repositories as well. So what you do, you try to, so in DFD diagram, let's suppose if I ask you to just stick to the level 0. So if you stick to the level 0, it means that you need only the basic inputs and outputs, and you have to represent the system overall. There is no need to divide the system or make the hierarchy. But if we talked about level 1 or level 2, so it means now you are going vertically downwards and as well as horizontally. So it means you are extending the system, you are adding more details into the system. Similarly, in the ERD diagrams, in the class diagrams, if you just use the basic symbols to represent something, it means you have not added the details. But let's suppose if we're talking about time-related concepts, let's suppose we're talking about space-related concepts. Let's suppose if I ask you to represent a model which has some space-related concepts, and at the same time, time-related concepts. So you need to have a detailed model where you have all all the symbols available to represent those concepts. So there are many models which are being proposed. The basic model for the relational database model is, as you know, is the entity relationship model. But we have lots of extensions of extended entity relationship models. So all of those are called extensions. So there are numerous extensions of those models, and we will discuss some of them. But of course, at the end of the presentation, I'll show you in a summary diagram that there are various models which have been proposed, which have been used, and it's up to us that which model best suits for our problem. This presentation or this topic is, of course, very important, because at the end of the topic, I'll try to give you some case studies, and I'll ask you to develop the models. So try to understand those concepts. So we talked about the different levels of details, level of abstraction. So abstraction itself is what? Abstraction means that you represent the concepts which are relevant to the given problem, to the given domain. What you do is you add into the model, and whatever you think are not relevant with the system and are not means in the scope of the given problem, what you do is you leave out. Very simple, like we make class models, we make classes. Making a class itself is an abstraction. So what you do, you add those attributes which are required, you add those behaviors which are required, and you leave out all those characteristics which are not relevant in the given problem. So that process itself is called an abstraction. and that simplifies your model as well. So there is no need to unnecessarily add the details which are not related to your problem. So that is important. The purpose of model. What is the purpose of model? Number one, creating a model can help clarify and refine the design. No issue. It is very clear that whenever you want to go for a design, you need to have a model. And of course, that will clarify or refine the design. That will help you out to understand the concept. Developing the model raises questions that need to be considered. That is very important. So whenever you have been asked to develop those models, I'll also interrogate, or I will also ask questions to you that how this concept is being represented. Why not you have used this way to represent that particular concept? So whenever you develop models, it gives freedom to the people to understand what actually it represents. So the question automatically raised कि यार ये सही है ये गलत है. जब भी हम किसी चीज को मॉडल करेंगे, डायग्राम बनाएंगे, तो समझ में आने लगता है कि इसमें क्या गलत है क्या सही है. Model helps to simplify complex aspects of the system, of course, no doubt about it. Whenever we make models, complexities are resolved. Always remember that if you are making such models which raise the complexity, it means the model is not correct. Believe me, if model itself creates complexity, then leave it for a moment. Try to understand, because if you make it more complex, then nobody will understand. That how it will lead to the detailed design. So simplification of the problem is very important. How to simplify the complex problem, चाहे वो जितना भी complex क्यों ना हो. अच्छा, uh, जी. So reasons for modeling. Number one, of course, learning from the modeling process. So what we do is we learn from the modeling. That is why we model. Some students may ask, okay, why there is need of model. Let's suppose we understood the concept, and please allow me to build that database directly. You can do it, no problem. Once you have the concept in your mind, even you can develop the database directly. You just go and create tables and make links, create constraints, and start adding the data and try to have queries. You can do it. But if you go by the process, uh, it is not recommended. Whenever you have a given problem, you have to model it first. Why? Because the modeling gives you the opportunity to correct your process, to correct your idea, to correct your concept. And obviously, when you go for the development and everything, then it will be difficult to identify what went wrong. So it is always recommended to have the modeling process. Number two, new pieces are found during the modeling to be added. Yes, sometime new piece of information is found and during the modeling, and if it is there, you have to add it. And we know that even when we are in the modeling stage, requirements continuously sometimes changing, or sometimes there are new requirements as well. So we must be able to include all these things in the model. New question arise that need to be answered to complete the model. So of course, whenever you have new situations, new questions may arise. Let's suppose right now, if let's suppose I ask you to make a relationship of a spatial entity. Now you think for a moment, because you don't know how spatial entity has to be represented in the database. So of course, when you model it, then you will realize that how that spatial entity need to be connected. So of course, whenever you have such questions in your mind, that how you have relationship of such entities, is it the same as we do in the normal ERDs, or what we have to add extra to reduce complexity that we have discussed? System can be complex and intangible. Yes, we know the systems are always complex and intangible, so we need to have model. This we have discussed earlier on. Model of parts of the system help to clarify and focus on important aspects. Exactly. We need to focus on all those aspects which are relevant, which are important. There is no need to waste time on all those things which are not relevant. Remembering all of the details. So it is always difficult to remember everything in your mind and just try to implement directly into the database, rather than what you do is when you make those models, that will help you to understand the complete concept. Okay, models are a way of strong that we have done. One other thing which is important in the modeling is that it supports the communication. What does it mean? That whenever we are working in a team, whenever we are working in the professional environment, we have to have meetings. We have to discuss how you comprehend the problem, how you have analyzed it, how you have determined those requirements. So if you build those models, that really help us to communicate among yourself. You share it with a group of people who are involved with you, and then try to resolve whatever the issues which are there. So because it's a standard language, because it's a standard way actually, ERD itself is a standard. So if you have your information in a standardized manner, that will help you people to communicate with each other, communicate in the variety of users, stakeholder as well. You can also involve sometime users for your feedback. So once you have those models, you on the basis of those models you can build prototypes, and you can involve users so that they can give your feedback. Because nowadays that working environment, that is our working model nowadays. Most of the time we involve users all the time. And of course, when we talk about agile development, in agile development we have to move forward. We have to make scrums, and we quickly we can add things, and we can involve users all the time. Users often work with analysts to create model. Yes, this is the functional approach right now, and people are using it. Issues for object-based modeling. Criterion: what is an entity? Can a relationship be an entity? Identity: how to tell the difference between entities? Now different ideas about objects. So when we talk about objects, issues for object-based modeling, maybe what is the criterion for an entity? What entity should be? किसको मैं entity मानूंगा? What is an entity? So entity is anything, in my point of view, entity is anything which has a significance in your system. Anything which has significance in your system, in your given problem, it means that you want to have that data regarding that particular entity. That entity can be anything. Entity can be an event, and entity can be an any